Let's start off with reviewing carbohydrate breakdown and catabolism of carbohydrates in order to generate our ATP. We can either do it in without oxygen. That's what we call anaerobic. There's anaerobic generation of ATP, and then there's aerobic. What is the difference? Well, one requires oxygen as a final electron acceptor. It means in order for aerobic respiration and generation of ATP to occur, I need to have oxygen present. What are some of the anaerobic pathways? Well, the primary one that we want to know for class includes glycolysis. We will keep this as simple as possible. You do not need to know the enzymes and the steps. You just have to understand the process, start and then finish some of the intermediate steps. Glycolysis is the breakdown of a glucose molecule. Glucose has 6 carbons, so it is a 6-carbon chain. It is broken in half and split in two, and its final product at the end of glycolysis is what we call pyruvate. Pyruvate, pyruvic acid, and this is a 3-carbon chain. But look, 6 versus 3. So there are actually 2 pyruvate molecules that pass through because it's split from glucose. If I do not have oxygen present in an anaerobic state or an activity that's anaerobic, I will build up something we call lactic acid, or we can just say lactate. If I have a lot of lactate, what lactate does is it helps to regenerate. So we're going to put a little circle. It's something called NADH. And NADH helps to carry hydrogens, and hydrogens will help to generate ATP. So long story short, the ATP generated from glycolysis, there's only 4 that are made, 2 that are consumed, so what's the total left over? There are 4 ATP that are made through glycolysis. Well, with glycolysis, let me make a correction. The 4 ATP that were generated minus the 2 ATP that were consumed during the process of a glycolysis results in a net 2 ATP that are generated overall.